Okay, this is part two of chapter 13, renewable resources. And here we have oh boy, it's a doozy of a little graph here. And it compares the inverted U shape of the fish stock and to the catch per period and something called sustainable yield. And this is part of what's called the H. Scott Gordon model of fishing effort. So if you see the graph on the left, you have what's called yield functions as a function of fishing effort. So you got a yield function of effort of 10. They say in the book it could be 10 fishers, yield of 20 would be 20 fishers, and yield of 30 would be 30 fishers. And you see these are a straight line, and your book says that this is a function um, of the fish stocks for 10, 20, and 30 fishers. And the curved line represents the growth in the number of fish as a function of the fish stock. So when you have 10 fishers, I guess the amount of stock that is in relation to 10 fishers is a greater amount than the amount of stock that would be available to each of 30 fishers. That's the only way I can interpret this graph on the left. Now, if you take the stock and if you take the effort, this is the graph on the right, the effort of 10, and that looks to be a catch of 10. So that would be the first area, the first intersection right there. And then we would have an effort level of 20 with a catch of 20, and the next intersection on the sustainable yield, and then a effort level of 30 and a catch of 30. So the blue line is equal to the sustainable yield. So as long as you have 10 fishers catching C10, that is sustainable, and you'll be able to maintain your fish. Um, if you have 30 and catch more than C30, that is not sustainable. Okay, so now we have the Gordon fishery model, and this shows the trade-off between sustainable rent and the incentive to fish more. So this shows the tragedy of the commons and the perfect competition story. So what is being done here is we take the sustainable yield that we developed in figure 13.4, and then we in essence monetize it. So we take the amount of fish and we times it then by the price per fish, and we have ourselves total revenue. Now, while econ rent profit is obtained by effort one, I guess you might say a lesser amount of fisher people. Oh, by the way, the marginal cost is assumed to be constant, so it's going to be horizontal. You would have a rent from effort one. You can call this a economic rent. You can call this economic profit. It's kind of the story that I would teach in economics 130. So we have a monopoly situation there. Okay, so far so good, and the effort one is done when marginal cost is equal to social marginal revenue. Fishers, however, have every incentive to fish more, where their private marginal benefit is equal to their marginal cost. So they don't necessarily look at the social, they will equate their private marginal benefit to the marginal cost. It's the similar story that I went over with you in earlier chapters. And this is probably not sustainable for the fish. So this results of too much fishing going on. It's a tragedy of the commons because the ocean is not owned by everybody, by any one person. It's owned by everybody, and thus you fish until your own benefit equals your own cost. that's at effort level 3. And that's a perfect competition story because everybody's profit is being whittled away until you have an economic profit of 0. And unfortunately for the fish, this is absolutely not sustainable, as the fisher people are looking at their own individual incentives. Okay, and this ends the second section of this chapter.